Hi and welcome. I'm trying to learn particle physics, and after we've done particle physics today, the symmetry of a standard model, and after we've done it, we're gonna do wrist training. And you participate in the wrist training when it's at your own risk. Now, general relativity. Albert Einstein's much refined theory of gravity was founded on a symmetry too, one known as the equivalence principle. And this equivalence principle states that there is no practical difference between a body experiencing acceleration because of gravity and one experiencing an equivalent acceleration from a different source, such as the thrust of a rocket or the spin of a centrifuge. So it's the same acceleration, whether it is because of gravity or because someone pushes it. I don't know if it now pushes, but if it's something accelerates. From the equivalence principle, so this principle that everything has the same acceleration, whether it is by gravity or because it's spinned in a centrifuge, did Einstein develop his theory that yields everything from curved space-time and an expanding universe to black holes and gravitational waves rippling through space. Okay, based on that principle, that everything has an equivalence principle of acceleration. With that help, on that basis, he formed his theories to space-time, the expanding universe, black holes, and gravitational waves. Einstein's work revolutionized our view of a universe, but also spurred a great deal of interest in the role of symmetries and physical laws. Okay. The person who made something concrete and mathematical out of that was one of the greatest unsung heroines of modern physics, Emmy Noether, who formulated the theorem that today bears her name. See Emmy Noether's struggle, page 20. Simply stated, it says that symmetries lead to conservation laws. Now, what are conservation laws? Because by symmetry, it's something is conserved in its place. Maybe that is on page 20. Okay, there's Emmy Noether, and she had made something about symmetries lead to conservation laws. And these are more or less concrete and mathematical ideas about how, even if also in physics, things are based on symmetry. This formalized an idea intrinsic to, but unstated in, the two theories of gravity. Let's do that. This formalized an idea intrinsic to, but unstated in, the two theories of gravity. For another example, consider a puck placed on a very smooth, very large frozen lake. Where the puck slides, the lake is the same. Noether's theorem provides a general way of turning that statement of symmetry into a conservation law. Okay, there's a puck, whatever a puck is, placed on an ice, on a frozen lake. And the lake is the same, no matter if the puck slides over the lake or if it's standing there. Okay. And that is a statement of symmetry, and that has something to do with the conservation law. Conservation laws are the bread and butter of physics, mathematical shortcuts that allow us to compute physical quantities once and then never again. So it has to be one time just mathematically calculated, the physical quantities of something, and when its state stays the same. Whatever you start with, that is what you will end up with. Because energy can come more. A thing is a thing. It doesn't get more and not less. This is incredibly useful. Think how much trickier it would be if the number of hours in the day changed constantly and was conserved at 24. It is bad enough twice in the year when the clocks go forward or back. I'm not sure if the example fits. So I once mentioned it. Maybe that's the explanation with how standard model, why a stuff stays a stuff. Okay, that is enough for now. We're going to read on in the next part. If you were here for particle physics, you can go directly to the next part of particle physics. What we're going to do now with wrist training. If you participate in wrist training, that is better than honest. What is there instead? The arms next to us, hands on the fists, and we bring your fists down and up. That is the spotlight, and again down. Now the flashlight, and fists to the inside and on the outside. We're having 3 rules. The first rule is that we're stopping immediately as soon as there's pain. The second rule is that we're going only as far as we can go with a little bit of effort. And the next exercise, the magician, flat hands and to the inside and to the outside. And the third rule is that we're not overdoing it. We just want to strengthen, not to exhaust. So if you feel like taking a break, we have a lot of exercises, then do it. And now the pancake flipper. Flat hands and open them and close them. And now the T-Rex in the morning, flat hands out and bring them down and up. Now the T-Rex in the gym. If you do it without a tennis ball, then just make a strong fist with one, press onto the tennis ball with moderate force. And release again, and press again. Release, and press again. And we're switching, press again, and release, and press, and release, and press the last time. And now we're doing the cautious bit way. Place the fingertips of one hand and look with the fingernails of the other hand. Press a bit, and up slowly, close again slowly. And we're switching. Now we're quite done with our castle architect. Both arms out with fists and bring these fists to the inside. And then up to the outside. Down to the inside. And now down to the outsides. Up and to the inside. Now you can skip the next exercise. You grab anxious to the fever. Arm next to us, hands on to the fist, bring the fist down in deflection, and press carefully against it. And pull from the outside. And press it from the top. Now with from the bottom. And now the same with the other arm, hands on to the fist, bring it down in deflection. Press a bit against it. Pull from the outside a bit. Press a bit from the top. And from the bottom. And now the 5 days into Synfest director. Fists, open them, close, open, close, and last time open. And now the next exercise, the Bosco bridge. Flat hands and bend the little knuckles. Out a bit and open again. And bend again little knuckles and open again. And last time. Bend little knuckles and open again. Next exercise, you can skip it again. It's an intense one. The frog testing water temperature. Flat hands and bring them down with flat fingers. And up with strong fists. And down with flat fingers. And up with strong fists. And again down. And up. And the last time down. And up. And now, claw. Flat hands, and we close. Open again, and again close. Open, and the last time close. And open. And now, take the arms in, strong fists into flexion, and out extension, flat fingers. Again in, strong fists, flexion. Out extension, strong, flat fingers. And again, in, flexion, strong fists. And the last time out, extension, flat fingers. And in. Now the ice axe, flat hand, bend it at the knuckles, and press on all 4 fingers. And now again, and the other hand, bend it at the knuckles, and press on all 4 fingers. And now, last exercise, the unfolding rocket boosters. Long arms, strong fists, and bring the fists into flexion. Now out into extension, the wrists and flat fingers. And in, flexion, strong fists. Out, extension, flat fingers. And in, extension, strong fists. And the last time, out. And flexion, strong fists. And now relaxation, we go on with moderate pressure over the middle part of the lower arm, that is where the extensor digitorum muscle lies. And on the other arm. And that was the wrist strain. I thank you very much, and until next time.